This video is about polyprotic acids. Now the title might seem really strange and weird at first, however I'm sure that by the end of this video most people will think it's one of the easier topics for acids and bases in Year 11. Your syllabus says that you need to be able to write equations for the successive ionization of polyprotic acids. So we're going to start by looking at what a polyprotic acid is, and then towards the end of the video we are going to practice writing some ionization equations for these acids. Let's start off with the definitions. I've got three definitions: monoprotic, diprotic and triprotic, and I've highlighted the prefix in each of these words. These prefixes, mono, di and tri, you should recognize them from when we were naming covalent molecular compounds. For example, carbon monoxide, where mono meant one, or carbon dioxide, where di meant two, sulfur trioxide, where tri meant three. So these prefixes are telling you a number, and then the suffix protic, protic is referring to protons. So a monoprotic acid has one ionizable proton, where proton is equivalent to a H plus ion. So a monoprotic acid is a substance where one of the hydrogen atoms can be ionized to form H plus. In a diprotic acid there are two hydrogens you can ionize to form H plus. In a triprotic acid there are three. The term polyprotic that was used in the title is simply referring to any acids that have multiple, meaning greater than one ionizable protons. So polyprotic includes all diprotic and triprotic acids. Pretty much includes all acids except for monoprotic acids. Let's have a look at some of the examples of acids that you should be familiar with. Monoprotic acids include HCl, hydrochloric acid, and HNO3, which is nitric acid. We've done ionization equations for these types of acids back when we were looking at Arrhenius Theory or Bronsted-Lowry Theory. So for example, the HCl, if we're using Arrhenius Theory, can ionize to form H plus and Cl minus. But after that one proton has been released, there's no more protons which can be ionized from the chloride, so it's monoprotic. For the nitric acid, we get H plus and NO3 minus. Now some people get confused with the acetic acid because they see that it's got four hydrogens, so how can it be monoprotic? The key here is that we're talking about ionizable protons. With acetic acid you can ionize one proton to form H plus, and you also form acetate, but you can't then cause these hydrogens from the acetate to also form H plus. So only one hydrogen in that molecule can do that. This contrasts to the diprotic and triprotic acids. H2CO3, which is carbonic acid, and H2SO4, which is sulfuric acid, are both diprotic, and they can release both of these hydrogens as H plus ions. Phosphoric acid, H3PO4, is triprotic, and it can release three hydrogen ions. So together all of these acids would be called polyprotic acids. I don't think I mentioned this before, but the prefix poly is actually referring to many or multiple, and you should be able to think of some examples of words in the English language which do use poly as a prefix. For example, polygon, meaning a shape with many or multiple sides. Alright, the last thing that you need to be able to do is to write equations for the successive ionization of a polyprotic acid. The term successive in this sentence means that you're showing multiple steps that happen one after the other. Now there are two different ways which you can write your equations, and sometimes it depends on what the question is asking for. You can either write your equations based on Arrhenius theory, or you can write your equations based on Bronsted-Lowry theory. If the question specifies to use a particular acid-base theory, then you need to write your equations according to that theory. If it doesn't specify, then you get to choose. Just to make things clear to you, we're going to do our examples using both methods so that you get a feel for what sorts of things you need to write. So let's say the question asked, write an equation to show the successive ionization of sulfuric acid. Let's start with the Arrhenius theory. So we put the formula of sulfuric acid, and according to Arrhenius theory, this dissolves in water to make H+. So it releases one H+ ion, and then we've got still HSO4-. So that is the first step of the ionization of sulfuric acid. The second step is that this hydrogen sulfate ion can also ionize because there is a second ionizable proton. So we take HSO4-. This undergoes a reversible reaction because HSO4- is a weak acid to form H+ and sulfate. Each time we did this step, we removed one H+ ion, so the product went down by one hydrogen and the negative charge increased by 1. If we had to do the same type of equation but using Bronsted-Lowry theory, then we would need to involve water in our equations. So we'll start off with H2SO4, which was our starting product, plus H2O, because H2O in this circumstance is going to be the proton acceptor. They react together to form HSO4- plus hydronium ion. And then same as before, the hydrogen sulfate ion is able to also undergo a second step with a new water molecule to form sulfate and a second hydronium ion. So this has shown the successive ionization of sulfuric acid, and we've had to do two steps, one to show each of the ionizable protons that has been lost. The next question we're going to do is the successive ionization of phosphoric acid, H3PO4. If you would like, you can pause the video, have a go at writing the Arrhenius and Bronsted-Lowry successive ionization equations for this substance, and then unpause to check your answer. So according to Arrhenius theory, our H3PO4 is going to ionize to make H+. I hope that you remembered to include a reversible arrow because phosphoric acid is a weak acid, and it would make hydrogen ions plus dihydrogen phosphate. The dihydrogen phosphate still has two ionizable protons left, so it undergoes a second step. Once again with a reversible arrow to form H+ and hydrogen phosphate, HPO4 2-. And then the third step is the HPO4 2- loses its last proton. With the Bronsted-Lowry theory, the equation is going to be very similar, but in each of the steps it is going to be reacting with water molecules rather than just spontaneously ionizing. So it forms dihydrogen phosphate hydrogen phosphate, and the last step forms the phosphate ion. With these polyprotic acids, it is very simple once you understand what to do. You just have to recognize there are multiple ionizable hydrogens, and then in each step of the ionization equation, you remove one of those H+ ions. Make sure you read the question to know whether you need to use Arrhenius Theory or Bronsted-Lowry Theory, or whether you have a choice of both. And remember which acids are weak and which acids are strong, because that is going to influence whether you need to use a single direction arrow or a reversible arrow.